Good afternoon, class. This is calculus. We have to integrate and differentiate the following. Now, before we go to this question, let's consider y equals x raised to power n. Of course, the y all over the x is going to give us n times x. We are going to have nx raised to power n minus 1. That means we have differentiated. So that means if you differentiate x cubed, this will give us 3x squared. Because 3 times x, we are going to have 3x, then minus 1. Then that means we have differentiated. The y dx of this will give us this. This will give us the y all over dx. That is when y is equal to x, equal to y x cubed. Now, if you now want to know that integration is the opposite of differentiation, let's integrate this one back. You see that we get this one back. How? From here, this implies that our dy is equal to nx raised to power n minus 1 dx. So when we integrate dd, then we have y will give us what? nx raised to power n minus 1 plus 1. That means we have integrated. Then n minus 1 plus 1 plus constant. So minus 1 plus 1, minus 1 plus 1. So we are going to have y equals nx raised to power n all over n. So this will cancel this. So that means the answer becomes of x raised to power n. Of course, when we differentiate c, it's going to give us it. So we are going to have x raised to power n. So that shows that differentiation is the opposite of integrations. Differentiation is the opposite of integration. So we can look at this first question. This one, the y all over dx is going to give us 9x cubed minus 1. That 9x squared minus 4x plus 4. That is the differentiation. So that's the correct answer for this one. So if you want to differentiate this one, setting y equals 1 over x, we see the same as what? X raised to power minus 1. So dy all over dx is going to give us minus 1 multiplied by x raised to power minus 1. Then we will subtract minus 1. So this is going to give us dy dx. Now we finally gave us what? Minus x raised to power what? Minus 2. We say that's what? 1 over what? X squared. Minus 1 over x squared. Minus 1 over x squared. This minus is there. So this gives us minus 2. So that's the answer for that. Now, considering this log x, set y equals to log x, this e. Of course, e raised to power y here. E raised to power y is going to give us x. From this roots of log a, this b equals x. We say b raised to power s is equals to a. So that's the rule under log. So from this, we can say this is equal to this. So when we differentiate this one, we differentiate y. It's going to give us 1. So that will be what? 1 multiplied by e raised to power y dy. You have differentiated. Then when you differentiate x, it's going to give us 1 dx. Now from here, our dy all over dx is going to give us x to come and meet 1 over e raised to power y. Since our e raised to power y was x, so the answer is going to be 1 over x. So that is the answer. That's the answer. So that's the answer for the differentiations of log x plus e. So you can see it's the opposite of differentiation. It's like this one. If you differentiate this, if you integrate this one, 1 over x, if you integrate, it's going to give us this one back. Yes. So if you integrate, if y is given, let's say if y is equals to 1 over x. So the integral of this, which means that integral of y dy must give us integral of 1 over x dx. So this one is going to give us when dy. So we are going to have y will give us what? Log of x base e plus constant. Or we say y equals to ln x plus c. That's another form of getting that. Please take note. So we are moving further. I want to consider this. If I give that v equals to this and a equals to the find dA dv. Now this one is a matter of thinking very well. So let's apply dv. our dv dr from here. It's going to give us 3 times 4. That's what? 12 by r root. Subtract 1 square. That's our dv dr. Then dA dr is going to give us what? 8 pi r. We deduct 1 from that. So to find dA dr, so our dA dr here, dA dr is same as what?